Welcome to Science, Manthan. Let's kick off this explainer by imagining a pretty familiar scene. Your mom heads to a fabric shop, asks for 2 meters of cloth, and the shopkeeper whips out this long, rigid metal rod to cut it. Fast forward to later that day, a tailor is measuring you for a new outfit, but boom, they're using a flexible tape. And then there's your grandmother in the kitchen, just brilliantly eyeing up the size of something using nothing but the width of her fingers.
So this actually brings up a really fascinating question, something we're going to dive right into today. Why on earth did different people use such drastically different methods to measure things? I mean, how exactly did we go from basic physical guesswork to the kind of absolute universal precision we have today?
Okay, here's our quick roadmap for today's explainer. First, why do we measure? Second, ancient methods and their flaws. Third, the power of standard units. Fourth, picking the right tool. And finally, mastering accurate measurement. All right, jumping into section 1. Why do we measure? To really get this, we've got to travel back in time to an era way before laser levels and modern rulers were even a thing. You see, before things were standardized, people just used what they always had on hand, literally. They relied on their own body parts to measure the world. We're talking about the handspan, or blisht, or using finger width, the ungula, foot length, arm length, even how long your stride is when you walk. And hey, it makes sense, right? It was incredibly convenient. You didn't need a toolbox. Your body was your measuring kit. But yeah, there's a catch. Let's hit section 2, ancient methods and flaws. Spoiler alert, relying on the human body eventually caused some massive headaches. This scenario literally hits the nail on the head regarding that fatal flaw. Just imagine these two carpenters. If both get an order to build a shelf based purely on arm lengths, well, we're in trouble. Everyone's body is fundamentally different. A tall carpenter with long arms is going to build a wildly different shelf than a shorter carpenter. It's like if 5 of you measured a table with your hand spans, you'd get 5 completely different answers. It was total chaos, basically zero reliability for accurate work. But what's kind of cool is seeing how organized ancient people tried to be despite these bodily limitations. Look at these ancient Indian measurement systems. We see units like the Danusa, heavily used in architecture, or the Yojana, which literally shaped early town planning. And honestly, it hasn't completely vanished. Next time you see a traditional carpenter or tailor doing a quick finger width estimate, they're basically using the ancient ungula right in front of you. Okay, moving on to section 3, the power of standard units. Because obviously for global trade and science, rough estimates just weren't going to cut it anymore. To avoid a world where every single doorframe is a different size, scientists finally stepped in and created standard units. These are measurements that stay exactly the same, no matter where you are on the planet. Today, almost the entire world uses the International System of Units, or SI units. It was an absolute game changer. It gave us a reliable, universal language, with the meter, that lowercase m, locked in as our official unit of length. Now, obviously, we can't measure absolutely everything in pure meters. We have to scale things up or down. As you can see, for tiny things like the thickness of a wire or a seed, we drop down to millimeters. For your everyday stuff, pencils, phones, centimeters are perfect. We use the standard meter for things like room sizes or human height. And for the really big stuff, highway lengths or distances between cities, that's where the kilometer takes over. And here is the absolute genius of the whole thing. The metric system is perfectly based on the number 10. 10 millimeters in a centimeter, 100 centimeters in a meter, 1,000 meters in a kilometer. It's so clean. This base 10 foundation means you can convert units in your head without doing any crazy complicated math. So simple, but so incredibly effective. All right, section 4, picking the right tool. Because having a universal system is great, but it's really only half the puzzle. You still have to pick the right instrument for the job. I mean, you wouldn't use a tiny plastic 15-centimeter scale to measure a massive door, right? And you definitely wouldn't use a stiff wooden meter stick to measure someone's waist. You have to match the tool to the object. Small, rigid scale for your pencil, long, rigid scale for a blackboard, and not flexible measuring tape, it's the absolute best choice for clothes, bodies, or literally anything with a curve. Okay, bringing us home with section 5, mastering accurate measurement. Let's get practical and look at the exact techniques you need to make sure your numbers are actually right. It all boils down to 2 golden rules. First up, you have to place the scale properly. It needs to physically touch the object and sit perfectly parallel to it. If it's tilted even a tiny bit, your measurement is already wrong.
Second, and this is a big one, you have to read the scale directly at eye level. Your eye needs to be positioned right above the reading mark. So why is that eye level rule so absolutely crucial? Because if you don't do it, you get hit with what's called parallax error. This is basically a totally false reading that happens just because you're looking at the scale from a side angle. Seriously, just by tilting your head a little to the left or right, the markings line up differently with your object, and boom, your measurement is ruined. Always look straight down. Now, what if your ruler has been through the ringer? Maybe that zero mark is chipped off or completely rubbed away. Hey, don't panic. Actually, scratch that, it's super easy to fix. Just follow these 3 steps. First, start measuring from another completely clear mark, like the 1 centimeter line. Second, read the number at the far end of the object. And third, just subtract your starting value from that final number. The difference is your true length. Easy! All right, next challenge. Not everything in the real world is perfectly straight, right? We've got garlands, circular plates, round bottles. How do you accurately measure something curvy when you only have a straight, rigid ruler that flat out refuses to bend? Well, if you don't have a flexible tape handy, there's a brilliantly simple workaround. Enter the humble piece of thread. Step 1. Carefully lay the thread perfectly along the curve of the object. Step 2. Pinch your start and end points and pull the thread tight so it's perfectly straight. Step 3. Just measure that straight thread against your rigid ruler. It's basically a life hack for getting the exact measurement of a curve without any fancy gear. And that kind of brings us full circle, doesn't it? As this quote hits on perfectly, measurement really is the bridge between chaotic estimates and universally understood accuracy. From the ancient days of unstandardized handspans causing total confusion, to the incredible precision of SI units, down to clever little tricks like the thread method, we finally have the tools to understand our physical world with absolute certainty. So, the tools of science are right there in your hands, ready to bring some order to the world around you. What will you measure next? Like, subscribe, and share for such more science-related videos. Also, drop your comments and queries in the comment section. We will catch you in next one.